In this video, you'll be introduced to properties of logarithms. I have listed 7 properties of logarithms here that you'll need to know. And the first one is log base b of b equals 1. This comes straight from the rules of exponents, where if I had the base, which is b in this case, to the first power, remember the exponent is the output of the logarithm, equals b. So the input of the logarithm or argument is the output of the exponential. So b to the first equals b is equivalent to log base b of b equals 1. The second property, log base b of 1 equals 0, also comes from rules of exponents. The base of b to the 0 power equals 1. And we know that any non-zero number raised to the 0 power is equal to 1. So that's equivalent to log base b of 1 equals 0. The next two, log base b of b to the x equals x, and b to the log base b of x equals x, both come from the property, or the fact actually, that log and exponential are inverses. So if I had f of x equals b to the x and g of x equal to log base b of x, these two functions are inverses. So they are inverse functions. And we know from studying inverses that this would mean that f of g of x equals x and g of f of x equals x. So f of g of x, I'm taking the log base b of x and putting it into the function b to the x power as the exponent. So that would give us our b to the log base b of x. That would equal x. And then g of f of x would be taking b to the x and plugging it into the log function as the argument. And that would give us log base b of b to the x. And since the exponential and logarithmic functions are inverses, their composition would be x. Now these last 3 rules, we're going to use them to simplify logarithms. The first one, the product rule, says that if we have log base b of m times n, so 2 things multiplied in the argument inside of the logarithm, we can split it apart as log base b to the log base b of m plus log base b of n. So multiplication inside of the logarithm splits into addition, and it becomes 2 logarithms. The quotient rule says that log base b of m divided by n is equal to log base b of m minus log base b of n. The power rule says that if we have log base b of m to the k, then the k can actually come down in front, and we would have k times log base b of m. So exponents inside of the logarithm can come down in front. So keep these in mind. They're on the formula sheet, and you will be needing to use those to simplify logarithms. We're going to do a practice problem from Alex from the homework. It says use the log properties to fill in the missing numbers. So we have log base 2 of 4 plus log base 2 of 8. And we want to write it as log base 2 of some single number. So our property says that if we have log base b of a plus log base b of capital B, then we will get log base b of a times b. That was the product property. So if I have log base 2 of 4 plus log base 2 of 8, and I want to combine it, it becomes log base b of 4 times 8. And 4 times 8 is 32, so that's what I would write here. I would write 32. All right, this next one, notice that I have log base 5 of 1 over 64, and then they pull out a negative 3 in front. If you look back at the properties, that tells us we want to use the power rule. So I'm going to go ahead and write down the power rule. That negative 3 in front tells us to use the power rule. And I'm going to think of it like this. I'm going to think of log base 5 of 1 over 64 is equal to log base 5 of some number to the negative 3rd power. So the negative 3 is going to be the exponent. Now, 64 is 4 cubed, so 1 over 64 would be 4 to the negative 3. So 4 to the negative 3 is the same as 1 over 64. And then the power property or power rule says that that exponent can come down in front. And so that would be negative 3 log base 5 of 4. So what I would put here would be a 4. In the next 2 videos, we'll use the log properties some more to either expand into several logs or combine into a single log.